Hi guys, how you going? We're going to start our next topic called on functions, and I just want to go through some terminology for you first up, if I can. Um, Now, the idea of a function is it could be anything. It could be a straight line, it could be a polynomial, and I'll talk about those in another video. But obviously, when we start looking at functions, there are some information that you do need to know, some terminology. So, just running through this stuff here. Looking at the values here, so if a graph has an open circle at the end, like this one here you can see, then we know that the endpoint is actually not included in the data. Alright, so if a graph has a filled circle, then we know the endpoint is included. Alright, we'll show you that. Now if I want to represent a graph that is actually going to extend forever and ever and ever, we'd be talking about something that may go off to infinity. Then we would be looking at including an arrow there. Alright, so that's really important. Now there's two terms that you need to know. Again, we talk about in maths the domain of a function and the range of a function. So the domain is related to the set of possible values in the x direction, alright, and then the range is a set of values in the y direction. Alright, so there are two terms that we will use when we start looking at describing the domain and range of a function. So in exercise 3a, you actually have to look at doing the domain and range of a function here. Alright, so if we start looking at doing some of these, I think we'll get the idea about what we're doing. Now, you can see this value here is a closed circle. Now, the coordinate of that is -1, 3. So if I'm going to describe my domain for this set of data, so my domain, that's going to be equal to what? Well, it's going to be all the x values that are greater than or equal to -1. So that's all I have to do is x is greater than -1. My range, right? So we're looking at our y value. In this particular case, they're going to be less than 3. Right, so my y value is going to be less than or equal to 3. Right, so you get the idea of what we're doing there. This particular one here, we've got an open circle and a closed circle. So if when we're looking at our domain value here, we could say that our x value has to be greater than -1. But it could be also equal to 5. So our x value is somewhere between -1 and 5. Got the idea? Right, so, and then we start looking at our range, our y values. So our range, our y values lie between, well, it's got to be greater than 1, but it's got to be less than 3 and equal to 3. Now, we haven't really talked about these lines here yet, but we've got what we call asymptote lines. Asymptote lines are where the function can't be equal to. So in this case here, you can see that we've really got all values of x and y. So we've got x going off to infinity, we've got x going off to -infinity, but we know that x can't be equal to 2 there. So our domain D, right? So we've got x is equal to all real values. That's our terminology for all real values, except x not equal to 2. Right, and then we did the same thing for our y value. The range is y is equal to all real values, a funny looking e, and then we also have to say except y is not equal to -1. Okay, so y is not equal to -1. So we're describing those functions there in terms of those things. And when we've got something like a quadratic, we'll quickly look at e. Right, so we could say in terms of our x value, x could be any value, so we'd say our domain there, right, x is equal to all real values, can be any value. Our range, now we've got a minimum value here for our thing. Now that is in fact our closed dot because it's actually incorporating that thing. So we could say that y is greater than or equal to -1. Hope this helps you in terms of what you've got to do in terms of describing the range and domain of functions. I think it's really important to do that. Now I want to show you something to do with how you determine if something is a function or not. I'm going to call it the line test. Okay, so determining whether something is a function or not a function can be determined by this. And I just want to show you on my iPad how this works. Alright, so if we come down to the screen here, okay, it's just going a bit slow. Alright, so if I'm going to drag this point across, so we're saying the top bit there is a function, and that looks like it's a polynomial, and then the bottom one is not a function. So if we get you to think about why it's a function or not a function, if I just drag that point across, okay, what do you notice about this? Right, I'll give you a little bit of time to think about this. Okay, I might even ask you this in class. So what do we notice about this? Well, the one that's got a function there, if we start looking at that, that's only got one value for every one x value, or one y value for every x value. Here, when we start looking at these this particular thing, it's not a function. For the same x value, we've got more than one y value. Okay, this is called the vertical line test. Alright, so going through that, we can go and have a look at the data set there for that. So this function here that's not a function, right, if you're looking at the side over here, has in fact for one x value you've got two different y values. Alright, so now I'm going to just go through a couple of examples here. You can tell me whether it's a function or not a function. If I drag this line across, right, what do you notice about that? Okay, you've got a table of values, right? So you can see that for everything that we're doing here, that we only got basically one y value for every one x value. So in this particular case, this one here would be a function. That would be a linear function, by the way, wouldn't it? This one here looks like it's a sort of a quadratic type thing, dragging this thing across. Right, it's a little bit delayed on my in there. But you can see as we move this across that you're getting one value of x for every one value of y. Alright, so in terms of that, that means that that must be a function as well. Right? When we go to looking at something like this next one, right, I'm dragging that across. If I drag that across, what do we get? As I drag this back and forth, it's just a bit slower on my computer compared to my iPad. It's actually not working by the looks of it. So if you move that point along, looks like it's hung up. What you can see there on the table is we can see that for every x value here, we have a number of y values there, don't we? Alright, so that means that this is not a function. And then we'll look at the last example here, which is the equation of the circle. And it seems to have timed itself out, not working properly. But a circle, if we start looking at a circle, right, that definitely isn't a function either. Right, now if we go back to, I'll just get out of there and go back to our original document. So here we've got the vertical line test to determine whether the following are functions. Okay, so you can see for this one here, if I did my vertical line, that's got no two y values, so therefore that would be a function. This one here again, the same thing, doesn't cut the graph at any more than one point. And again, this one over here, so these are all functions in this first row. As I was saying with the circle, if I do a vertical line down through here, you will see that it touches at that point there, touches at this point here. So the vertical line test suggests that a circle is not a function. Right, this one here, that would be a function. This shape here cuts at 2 points, so therefore that's not a function. Alright, so you've got a couple of exercises to work your way through, making sure that you know how to use the concept of the domain range, and also coming down here to test whether something is a function or not a function. Alright, so have a go at those questions and have a look in your overview for this topic. You'll find the exercises that you need to do for this. And if you have troubles, need to make sure you catch me in class or talk to one of your classmates. See ya. We'll catch you later.